In this section, we'll be discussing the physical properties of alcohols, including their boiling point, miscibility, as well as their acidity. We've covered in the previous section that the defining feature of the structure of alcohols is that they possess an OH group. And this OH group allows them to engage in hydrogen bonding. So within the alcohols themselves, there's intermolecular hydrogen bonding. And when alcohols mix with other molecules such as water, it can also form hydrogen bonds. But the alcohols themselves also possess a hydrocarbon chain, which is still non-polar. If you have forgotten how to draw intermolecular hydrogen bonds between alcohol molecules, this diagram is on page 2 of the notes. So first is the boiling point. Compared to alkanes with similar molecular mass, the boiling points of alcohols is higher. This is because the intermolecular hydrogen bonds between alcohol molecules require more energy to overcome than instantaneous dipole-induced dipole interactions between alkane molecules that have similar molecular mass. Here are some factors affecting the boiling points of alcohols, which should not be unfamiliar to you. Firstly, as the number of carbon molecules in the alcohol increases, the boiling point will increase. So as you can see, methanol, the boiling point is the lowest, followed by ethanol, followed by propan-1-ol. Next, when an alcohol molecule has more branching, it results in a lower boiling point, and this is because the more branching there is in the alcohol molecule, it results in a lower surface area available for the formation of instantaneous dipole-induced dipole interactions, which results in a lower boiling point. Next, we'll talk about the solubility or miscibility of alcohols. So, the smaller alcohols from 1 to 3 carbons are able to engage in hydrogen bonding with water molecules and are thus completely miscible with water. In other words, you can mix them with water in all proportions. And this diagram shows the hydrogen bonding between water and alcohol molecules. However, once we go 4 carbons and beyond, the hydrocarbon chains in the alcohols get larger, and this results in the miscibility of alcohols decreasing significantly, because now, as the hydrocarbon chains get longer, the instantaneous dipole-induced dipole interactions between alcohol molecules become more significant, such that even though energy is released when hydrogen bonds are formed due to the mixing between alcohol and water molecules, this energy released becomes insufficient to overcome the ID-ID interactions between alcohol molecules as well as the hydrogen bonds between the water molecules. So mixing the alcohol molecules with water becomes energetically unfavorable, and this results in the solubility of the alcohol molecules decreasing in water. Finally, we're going to talk about the acidity of alcohols. Now, it may seem counterintuitive, but alcohols actually behave as weak acids. In fact, when you mix alcohols in water, they appear neutral, but that is because they are weaker acids than water, and they cannot protonate the water molecules. So there is this equilibrium, but the equilibrium position actually lies very far to the left. So the alcohols are dissociated only to a very small extent in water. And this species, the RO- ion, is the conjugate base of an alcohol. It is known as an alkoxide ion. So for example, if ethanol dissociates in water, we would say that the conjugate base is called ethoxide ion. So why are alcohols weaker than water? Okay, this is an explanation that you know how to write. And the reason that alcohols are weaker than water lies in the relative stability of the conjugate bases. So we will need to contrast the stability of alkoxide ion versus hydroxide ion, which is the conjugate base of water. So in the alkoxide ion, which is RO-, the alkyl group, or the R group, that is bonded to the oxygen atom, which bears a negative charge, is able to exert an electron donating inductive effect. And this O atom is already electron rich, bearing a negative charge. And when there is an electron donating alkyl group attached to this O atom, it will intensify the negative charge on the O atom, and this destabilizes the alkoxide ion compared to the hydroxide ion. In turn, since the alkoxide ion is less stable than hydroxide ion, this makes the alcohol a weaker acid than water.